In this example, we will find the third derivative of the function f of x equals e to the 3x plus sine 4x plus x to the half plus 1 over x squared. So really all we're doing is taking the first derivative, and then with that result of the first derivative, we will again apply another derivative, and then again we will have to differentiate the function a third time in order to find f triple prime of x. So before we get started, I'm just going to write down some key derivatives that we're going to have to use. The first is that the derivative with respect to x of e to the x is itself. The second is that the derivative of sine x is cos x. And the derivative of cos x is negative sine x. Don't forget that negative sign. And the last big one is d by dx of x to the n equals n times x to the n minus 1. So let's go start tackling this problem. Let's find the first derivative, f prime of x. So our first term is e to the 3x. So we know that the derivative of e to the x is itself. So I'm going to write e to the 3x, that's itself. But we have to use the chain rule, and I need to take the derivative of this exponent. So the derivative of 3x is just 3, so I have to multiply this function by 3. There's the first derivative of the first term. Now for the second term, I have sine of 4x. So the derivative of sine of anything will just be cos of that angle. So what I have here is plus cos of 4x. But I have to be careful here because again, I must apply the chain rule. Because I have this 4x here, I need to multiply this result with the derivative of that. So I will have to multiply by 4. Now, for the third term, I will have to multiply by a half. I'm just using this rule right here. So it's going to be 1/2 x to the negative 1/2. Because negative 1/2 equals 1/2 minus 1. For the very last derivative here, I'm just going to rewrite this last one as x to the negative 2. Because now I can see how I'm going to use this rule here. So I'll be left with, I must multiply by negative 2, so this term becomes negative 2 times x to the negative 2 minus 1, which is negative 3. So I've found the first derivative. Now, I'm just going to differentiate this one now with respect to x. So f double prime of x will equal, so I'm going to have itself again for this e to the x, so it'll be 3e to the 3x, but I have to apply the chain rule again, so I'm going to get another 3 multiplied here. And now, for this next one, I'm going to have 4 sine 4x with a negative sign, because the derivative of cos is negative sine. So I'm going to have minus 4 sine 4x, but again I must apply another chain rule, so you can kind of see this pattern. I'll have another factor of 4 coming out from the chain. And now for this one here, I have to multiply by negative 1/2. So this will now become negative 1/2 times 1/2 x to the negative 3 over 2. And now for this one, I have to multiply negative 2 by negative 3. So this becomes positive 6x, and I'm subtracting 1 from the exponent, so it'll be to the negative 4. So I might as well simplify these out here, just to make it easier to take the next derivative, because I have to take another one. Okay, so I have the second derivative. I have to apply the differentiation one last time. So again, I will have 9e to the 3x times 3, because of the chain rule. So this will be 9 times 3, which is 27 e to the 3x. Now I will have minus 16 cos 4x, but I have to multiply this by 4 because of the chain rule again. So this will be 16 times 4, which is negative 64 cos 4x. And now I have to have minus 1/4 times negative 3 over 2 x to the negative 5 over 2, because I got to subtract another one out of there. So I got to subtract 2 halves. Now I have to do negative 4 times 6, so this is going to be negative 24 x to the negative 5. So now let's simplify this out. And this is what we get for the third derivative. Here's one for you guys to try on your own. Find the fourth derivative of x cubed plus 2e to the x plus sine x. And here's the solution.